Yes, welcome back to the channel. So in this video we are just looking at some points which somebody regards to as the important points. Okay, important points are this. Apparently the length is one of the important points, guys. Relax, it's just you knowing what is being regarded as important by teachers. So the length formula, you know it. Whenever you are required to calculate the length between any 2 points, then you have their coordinates. You can use this formula, guys. It really works whenever. Whether it's between 2 points out of nowhere or 2 points which happen to be your what is it, the x-intercepts for a hyperbola, not a parabola, not a hyperbola. Hey, Jesus. When it happens to be those, you can still use the formula sometimes and then you will be fine. As long as you have the coordinates, you can use the formula. And then there's a vertical line. A vertical line, just remember that whenever you have a vertical line, the equation of that vertical line is just x equals to a certain number. K is just a value. So basically, okay, how can I demonstrate that? Let me draw the xy plane, and then we have a vertical line like that. It touches this somewhere. It touches the xy plane. That is that number that we are talking about. That when we say the equation of that is x equals to a certain number, we just mean the number where it touches this x-axis. If that was 3, that becomes 3. That's the equation of the vertical line. And the equation of the horizontal line on the other side, we can have the horizontal line touching the y-axis there. That is exactly the value of the equation. So it's going to be y equals to that value. If that is 4, that means y is equals to 4. That's the equation of the horizontal line. You don't need to try to determine the equation using that thing of y equals to mx plus c or y minus y1 equals to m into x minus x1. You will be wasting your time and getting chowed by course if you try that. Just y equals to some number or x equals to some number if you are dealing with a horizontal or a vertical line. I hope we are clear. We move on. Okay. Sometimes we have this notation. This notation is the xy notation. Remember f at x, I said it's y, so this means x, y. That's basically the situation. So don't stress yourself too much worrying about these things. Hey, guys, I'm trying to quickly finish this thing before my space gets occupied. Nonetheless, let's continue. Completing the square. Completing the square is just a way of changing this equation into this format. So that's basically what you can do. Complete the square, change this equation into that format, and then you will realize that when you complete the square from this equation, you will have y equals to that. And oh no, before I lied to you, when you complete the square, you'll have this format being changed to that format. That's fine. And in one of the ways, you will realize that that p there is equals to this. That p is equals to that. The positive p, I'm not saying minus p is equals to this, I'm saying p. I hope that is clear. And then to get the what you call the corresponding y value, just substitute the x value into the equation, then you get corresponding y value. That's it, and then you are fine. Lastly, we have this rationalizing the hyperbolic function. This is just a way of converting this format into the standard format that we are used to for hyperbolas. We'll do a couple of examples, you'll be fine. There's an average gradient. You can use this to get the average gradient, and there's maxima and minima. When you have a turning point like that, turning point like this is a minimum, min, max. That's it. Then move on.